And the next one is using similar triangles to find like indirect measurements. So that's just like a measurement or we're going to find a measurement of something without actually measuring it. Okay. For example, we're going to find Brad's shadow without actually using a measuring tape. Okay. So watch, it says a tree 24 feet tall. So imagine we have a tree and it's 24 feet tall, so it goes like this, right? And then it casts a shadow 12 feet long. Now the shadow is going across this way. Now I imagine you guys are thinking, well, which way is the sun? So let's say the sun is here. So let me color this in so you guys will be like, yeah, that's the sun. So that's the sun. The sun rays are coming up this way. So again, it's not hard to think, hey, the shadow should be going across the bottom. So that's kind of the tree information. Then it says Brad is 6 feet tall. So here's Brad. Hey everybody, I'm Brad. And he's 6 feet tall. And the question is, how long is Brad's shadow? So how long would his shadow be? So I'm just going to put an X there for his shadow. And again, I said we're going to use similar triangles, and some of you guys are probably thinking, well, where the heck is the triangles? Here's the triangles. The triangle goes from here to here. That's the tree triangle. You can call it, and it's a right triangle. And then this one we can call the Brad triangle. Okay. And they are similar triangles. I'm not going to get into why they're similar triangles right now. You can look back at the notes to figure that out or to find that out. But these are similar triangles. And because they're similar triangles, I can write a proportion to find Brad's shadow. Okay. Again, I'm going to look at the tree I'm going to call this the tree triangle. The tree triangle has two measurements. 24 is the height of the tree, and 12 is the tree's shadow. And then I put the corresponding sides underneath that. The corresponding sides for Brad's triangle would look like this. 6 is Brad's height, and X is Brad's shadow, and his shadow length, and that's what we're looking for. And then again, cross multiply, so you don't grab the letter, divide by 24, and you get X equals 3 feet. Okay, 3 feet. And that's number 8. And then number 9 looks like this. A 40-foot flagpole. So imagine, here's the good old, I don't even know how to draw a flag. The red, white, and blue. And it's 40 feet high. And then it says it casts a 25-foot shadow. So the shadow is 25 feet. Now I made this kind of small because then it says find the shadow cast by a nearby building 200 feet tall. So the building's huge. And just imagine this is the building, right? And then the question, it's 200 feet tall. And the question is, what kind of, or how long would a shadow be for this building? Again, here's our triangles. They look like this. And because these are similar triangles, I can write, or we can write this proportion to solve it. Let's got to make sure this is in the video. Yeah. So let's use the flagpole triangle. The flagpole height is 40. The shadow of the flagpole is 25. Now let's look at the building triangle. The height of the building is 200. And the shadow is actually what we're looking for of the building. Okay. So those are the proportional sides. Cross multiply. Divide. And we get 125. So the shadow length is 125 feet. Okay. Just pause that real quick. I'm going to flip it over and get to number 10. Number 10 is tricky because the two triangles are overlapping. Okay. So it says a girl 160 meters tall stands 360 centimeters from a lamppost. So imagine, here we have a lamppost. Let's give this guy some light. So there's the lamppost, right? And they tell us a girl, this girl over here, the girl with the hair. See how she's different than the boy? Well, boys have long hair too, though. Anyway, so the girl this girl is 160 centimeters tall, so her height is 160, and it says she stands 360 centimeters away from a lamppost. So this distance is 360 centimeters. Her shadow from the light is 90 centimeters long. So this is shining the light, and it's casting her shadow, and the shadow is 90 centimeters long. How high is the lamppost? So how tall is the lamppost? See, now that's tricky because this is how the two triangles are overlapping. I said they were overlapping a second ago, right? This is the distance from the girl to the lamppost. This is the girl's shadow, and then this is how tall the girl is. Okay, and we want to find the height of the lamppost. What I like to do is separate them. Separate them so they look like before. So this is the girl triangle. The girl triangle, we have the two numbers we need. And then the lamppost triangle, well, we know this is X. And then this is where it's a bit tricky. Some students just want to put 360 down here, but this entire length is actually 360 plus 90. So you need to add these. And when you add them, or when we add them, we get 450. Okay. So now we can say, okay, I'm going to look at these two triangles and write the proportion. So that's the lamp post, and this is the girl. So the lamppost triangle, the height is what we're looking for, and the shadow length is 450. And the girl triangle, her height is 160, and her shadow is 90. Cross multiply, divide, 160 times 450 divided by 90, and we get 800. And that would be 800 centimeters, okay?